Hey everybody, welcome to tonight's show. Today we are going to be discussing material science, the coolest in new technology, sort of the materials of the future. What are we going to need for some of the inventions in medicine, technology, science, all the rest? Some of it is mind-blowing, everything from interdimensional superfluids to self-healing metals and even recovered parts of UFOs and metamaterials. We're going to get into everything today. It's going to be a fantastic show. So thank you for joining us. Let's get started. Welcome back to Quantum Matter Podcast. My name is Louis Borges. Joining me as always, my good friend and co-host, Mr. Marquise Williams.
What's up, everybody? This is I've got some interesting perspectives about a lot of the topics we're going to talk about tonight. I've had thoughts about these, especially the nanotechnology, forever. So it's going to be interesting. Plus, I want to give a kind of shout out to some people that are watching the podcast in my personal life. If you're watching, thank you for letting me know that you guys like the content. There's people that actually know me locally where I live that have been saying, hey, I watch your podcast, man. I learned so much stuff about science and all these different technologies that I never thought about. And I'm like, it's just really cool. It's cool to see that people are actually paying attention to us and that in my personal life. So shout out to you guys. And of course, to all of the listeners that have been with us and stuck with us since the beginning.
For sure, yeah. And if you like our show, do us a favor, send it to a friend, right? Share our episodes, talk about it. Let's get some people going in our chat rooms every Thursday. If, when you start off slow, all the numbers are slow and everything else. But if eventually we only have 15 or 20 people in the chat room, it's not going to make much sense for us doing live shows on Thursdays. So if you like what you're seeing and you want to keep it going, send your support. You can join our Quantum Club for free. Show us that you care. And if you have any questions, topic suggestions, guest ideas, anything like that, let us know. We want this show to be for you. So let's interact because it's for you. And thank you, everybody in the chat room, those loyal people that always hang out with us. We know all of you. We respect you all, and we really appreciate it. And also everybody in the world of YouTube, Spotify, Apple Podcasts, and the UnX Network on Sunday night. So thank you all for all your continued support. And we couldn't do a show without saying thank you to our sponsor, H2 Water Expert, for all of your hydrogen therapy and water filtration needs. Check out h2waterexpert.com or click the link in the description. So we got a lot of videos and a lot of clips. I don't know if we'll get time to do all of it today. We're going to move rather quick to get as much in as we can because a lot of this stuff is mind-blowing. It's amazing. We are not PhD scientists, so we can't do too deep a dive on a lot of this. And a lot of this is up and coming. There are no pictures. There might be simulations or mock-ups, but a lot of this stuff is theory and it's in progress. So we're going to show you what we already have. We're going to show you what people are working on and what that looks like in the next 20 or 30 years. Basically, if we do it right, a lot of things can improve, not only with the environment, but with manufacturing, the products we use. I mean, picture a phone with a broken screen that can heal itself. There is such a technology, and we'll show you. Or imagine a plane that sustains damage and can heal the wing mid-flight. These are all the possibilities with the type of material science we're going to get into. So let's start off with a clip on what is material science, and then we'll show you some examples and go from there.
Materials science is the driving force behind our technology-driven world. With new materials increasing the possibilities of technology, let's look back at some of the most interesting materials we looked at in 2022. When it comes to technology, silicon is important.
Silicon is the king of materials in the chip industry.
Silicon is a semiconductor, meaning that its conductive properties can be increased by mixing it with other materials such as phosphorus or boron. This allows for the electrical current to turn on or off. Or how about materials that possibly come from space or further afield? Nitinol was discovered by a brilliant young scientist named William J. Buehler. Buehler was a metallurgist at the Naval Ordnance Labs. Buehler selected roughly 60 alloys for further examination from a book entitled Constitution of Binary Alloys, nitinol being one of them. He named his alloy nitinol for Nickel Titanium Naval Ordnance Laboratories. The shape memory aspect of nitinol was discovered in 1961 during a lab meeting. During a demonstration, his technician was showing senior officials the fatigue properties of the metal. At this presentation, one of the officials present heated the nitinol with a lighter, at which point it rapidly straightened out. Maybe the advancement in 3D printing became awe-inspiring to see. From building toys and simple models to even printing 3D guns. The most bizarre, and the one everyone is waiting to see, is printing human cells. Research at the Wyss Institute has led to the development of a multi-material 3D bioprinting method that generates tissue of living human cells that are nearly 10-fold thicker than previously engineered tissues. This innovative bioprinting approach can be modified to create various vascularized 3D tissues for regenerative medicine and drug-tested endeavors. Imagine we could print new organs and other parts of the body, or have them repair parts within the body. Or perhaps the world of self-repairing materials is more interesting to you. Self-healing materials are considered to fall under these four types: materials with embedded healing agents, materials with a kind of internal vascular circulation, shape memory materials, and reversible polymers. Embedded healing agents have built-in microcapsules filled with a glue-like chemical that can repair the damage. If the material cracks inside, the capsules break open. Unfortunately, the capsules have to be so small that they weaken the material they embed, and this limits the amount of damage they can fix. Then we have reversible polymers. Thermoplastics have been designed so if they are cracked or damaged and then heated, the polymers will break down into their monomers. This method does rely on having a supply of heat nearby. Tests have been conducted by firing bullets at the materials. The heat from the impact effectively lets the polymer reseal the hole and bind the material together again. We all now have devices that use lithium-ion rechargeable batteries. Over time, these batteries degrade, start to bloat, and eventually ruin the device the battery is in or become a fire hazard. Researchers at the University of Illinois have developed a self-healing electrode. The electrode causes a reaction in the microcapsules and disperses throughout the crack-filling materials to make the battery safe. In 2023, we will see even more creative and obscure materials.
There is a lot packed into that video. So we went from this, this nitinol, which is like some kind of in my opinion, it's like a magic material in the science world. And as he said, nitinol is like it's like this alloy of nickel and titanium that has what they call a shape memory effect. So kind of imagine bending a spoon like just by looking at it the wrong way. That's what this nitinol stuff is like, at least analogously. That's what I would consider it. So that's kind of what's happening with this. It deforms, and if you warm it up, it snaps right back to its original shape, which kind of goes into the next part of what we talked about in that video, which was 3D printing, which I know everybody knows what that is. There was a lot of controversy with 3D printing when it first came out, for years, there's been a lot of controversy because people have been 3D printing things they're not supposed to, illegal things, like, I don't want to get too into it, but weapons and certain materials that are copyright material. They've been 3D printing them so that because they can't afford them, and it's a lot cheaper. Now, the benefit, of course, is that with 3D printing, you can have people or mass production for most of our material. The idea of made in China could be a thing of the past if everyone could have a 3D printer that might cost as much as a microwave. I mean, literally, if in a 5 to 10 years, you might be able to buy a 3D printer for the cost of a microwave, and then 3D print some of the small items that you need much better than they do today, because it's not very good today. It's okay, but it's not very good today. Anybody could do that. There are kids right now who are 3D printing like models that they need for parts in their computer or in other electronic devices. They can 3D print them. So that's kind of how I see it. You can also 3D print food, which I know this sounds crazy, but putting it in a material that can essentially, when you use it through the 3D printer, produce any kind of food that you want. Well, I don't know how far that can go, but I can just imagine some at least basic needs that people can have. They can through food. They can have easily through 3D printing. So forget the made in China, which is a big problem for the U.S. now because we're dependent on those products. Now it could be made in your home. Forget about where it's made. It could be made in your home. Most things. So yeah, there's a lot. That video was packed full of a lot of different things. I don't want to get too into it because I know you're going to go over a lot of stuff. But
yeah, we got lots to cover here. And they mentioned, the printing of the organs. We always talk about there being a lack of donors and everything else. Well, even if you get a donor organ, you still have the risk of rejection. It's not your organ and your body knows it. Yeah. So you're taking immunosuppressants for the rest of your life, which have their own side effects as well. But this could actually be products made from your own tissue, which is like an external kidney grown in a lab. And you would not need a donor. I mean, here is a blood vessel. They call them bioprinting. So it's 3D printing biomass. But we've seen printed steaks in a lab and all kinds of weird stuff. The cool thing I thought that they brought up was the self-healing material. And a lot of scientists in Japan are really going over all this here. But it's basically a self-healing fluorescent material. It offers a potential for more durable organic solar cells and more broad applications. Even things like computer screens and cell phones. Here's roughly how it works. So they take that flower picture, they cut it, and then it heals itself within 2 hours. And then daylight can actually make something more flexible, or even UV can make something go from being solid to elastic as well. We'll fly through some of the application examples here. But basically, these are essentially metamaterials, things that were thought to be foreign many years ago, and they aren't anymore, right? So here we go. Titanium fluoride phosphate material, which is basically used in sort of like batteries. They're using it as the cathode end of the battery because of its electrochemical potential, its stability at high charge and discharge, and it outperforms the current materials that we're using of lithium and cobalt, which are also expensive and are diminishing in supply. Cellulose nanofibers. We've talked about carbon nanofibers, but this is basically made from like cornstarch, right? Cellulose is existent in plant fiber. So it creates a super strong biodegradable material from wood in this case. And the unique nanostructure of this material provides a tensile stiffness of 86 gigapascals, which is a lot. Basically 8 times stronger than spider silk. This is considered to be the strongest biomaterial, stronger than steel and much lighter. And it's also eco-friendly. Self-healing gels. These are kind of cool. It's a material made from aminopropyl methacrylamides, or APMAs, polymer glucose, glucose oxidase, and chloroplast. They basically continuously react with carbon dioxide from the air. They expand, they become stronger. So even if something breaks, this continuous chemical reaction is always happening, and it's always healing itself. It's kind of like us regenerating cells. What cells will die off and get damaged, but there are new healthy ones coming in behind that. So essentially, you're making a material that can access carbon, and there's a ton of carbon around us, and this is all being done through MIT. Platinum gold alloy. So a gold platinum alloy is 100 times more abrasion resistant than steel, even at high temps. It has excellent thermal stability, and basically you're changing the grain in the energy. So metallurgists and people that make knives and bladesmiths, They know about heating and cooling metals to affect the grain size. Too slow or too fast, can make the metal brittle rather than flexible. So that's something that's fairly well known already. Composite metal foams. Basically, it's a hollow metallic sphere made from things like steel or titanium, embedded in a type of matrix, which could be made of steel or aluminum. So the steel to steel CMF is so called that because both the spheres and the matrix are made of steel. It's much more fire resistant than a solid steel plate. And in addition, the steel CMF panel is only 1/3 of the weight. So imagine this kind of like corrugated cardboard. It's stronger than a single sheet of cardboard, but it's only because of that inner layer, that sort of corrugated layer that gives it that matrix strength, right? Spider silk is already regarded one of the strongest materials, but now scientists are discovering another unique feature. So above a certain level of humidity, the spider silk suddenly contracts and twists. It's called supercontraction, kind of like that nitinol we talked about earlier. It exerts enough torsional force to compete with other materials for things like actuators or control devices. So basically replacing machinery. And then this stuff here, shilk. Basically, it is shrimp silk. I know that sounds crazy, but this is biologically inspired. It's a biodegradable plastic, so it's composed of chitosan or chitosan, which is a component in that hard the shrimp shell, and then they mix that with a silk protein called fibroin. So shilk is as strong as aluminum, 50% lighter. Its biocompatibility, flexibility, and strength makes it attractive for medical implants. Carbon concrete. So how do you reinforce concrete with carbon fiber rather than rebar? The rebar is the weakest part of the bridge. When the rebar rusts, it basically corrodes the bridges from the inside out. So how do we prevent that moving forward? We know carbon fiber is used in so many applications, aviation, automotive, all the rest. Why not implant that into buildings and bridges, thereby extending their lifespan? And then aerogel. So it's a porous ultralight material. It's basically all air. It's 99.8% empty space. But the supercritical drying of liquid gels such as alumina, chromia, tin oxide, or carbon makes the material strong enough to carry 20,000 times its own weight. So aerogels are open porous, meaning the gas in the aerogel is not trapped inside. So it has pores. Again, this is at the nanoscale. So it's kind of like a miniature sponge, essentially, right? Lightweight, but you can pack a lot of stuff in there to keep its form, and it has a low conductivity, so it's very good insulation. And then there's a picture of that shrilk right there. This kind of looks like dead skin, which basically is what it is. Essentially, it's protein and like fingernail material, but that's basically just some of the applications right now. And in the medical field, they're actually designing. Here's an ad that I found. So an algorithm is designing proteins from scratch that can bind drugs. So that's for like targeting medication. You can target a drug to bind to cancer because it can create the protein it needs to be able to lock with that perfectly. So it's like 3D printing cures for disease because you can manufacture the material and you can align it in such a way. And there's a lot to do. I've been reading a lot about proteins lately, and it's all about how they fold. I mean, if you look at the length of our DNA, it's ridiculous. I forget how long it is, but it like goes around the planet or something like that. Yeah. All because they're twisted and coiled on themselves numerous times, and every protein folds differently and has different information contained within it. So a lot of things right now in the medical world and dealing with how do we fix disease and DNA issues and things like that. A lot of that is we're not producing the right proteins, or we have a deficiency or the inability to produce cells correctly, which is basically protein synthesis. So if you could design proteins from scratch, you could supplement ones that we don't have, or you could create new proteins to bind with things that we find less desirable, like disease or, things within our body as well. I thought that was pretty cool. And light particles. So they call these polar items or polaritons. I think that's what it is, polaritons. So it's half light and half matter. These are, again, at the nano level, but this is a hybrid particle. So it has the behavioral characteristics of both light as well as solid matter. So we're talking about things like television, screens, next generation materials that definitely surpass the performance of what we have now. So right now, the inability to electronically control polaritons at room temperature or at a single particle level has kind of hindered their commercial viability. These need to be done at extreme temperatures again. And another one I found, this was kind of cool too. They've discovered a bacteria that allows plants to grow in polluted soil. So even if the plants are growing in soils that have heavy metals or metals we would deem to be like toxic, this bacteria, it's in some wild soils, and it will acquire a set of genes that allows it to filter out the heavy metal nickel, which is toxic. But since nickel naturally occurs in soil and water, some plants have adapted to be able to pump that metal out of their system. So through years and years of them coexisting with heavy metals, they found a way to get rid of the metal. It's like when you see an iguana at the beach and they're shooting salt water out of their nose. It's a way of regulating, I'm talking about sea iguanas, but it's a way of regulating their saline concentrations in their body. So they can literally drink and eat fish underwater, and then they eject the extra salt out their nostrils. It's kind of the same thing with the plant. It's going to take in the heavy metal, but it's acquired genes through bacteria that can remove that. So it's like it has its own detox system built in. So, I mean, imagine what that could do in the future, Marquise.
Yeah. Listen, my mind always goes to sci-fi. You know this, right? So there's a couple things I want to say. So I was thinking about Neri Oxman, which one day I hope that we can get her on the show and have a conversation with her. That would be freaking awesome. Where she taught, and if you guys don't know who she is, she's working on a way to essentially blend nature and architecture together. She's literally a pioneer in the field of material ecology, which is a new field that I never knew was a thing. Material ecology. So she essentially finds things in nature that, as you were just talking about, you can use like the silk from a silkworm to create entire structures that kind of build themselves through manipulating the way they build their own silk structures. So it's really interesting. You have to see for yourself. Just look up Neri Oxman on the internet. I don't have any images of her right at the moment and some of her work, but it's littered. It's littered all over the internet, all over X. You'll see some of it. You could essentially blend instead of having structures that are made out of like wood, which we have to cut down trees to get, or that are made out of metal. You can make material that are far stronger than the base material of like wood, but that, as you said, heal and also can be replaced by just adding new organic material that grows itself. You don't have to worry about ever again anything happening to your house and then having to worry about damages. You can just regrow it. That's the idea of blending nature and architecture. That in my mind, I think of sci-fi movies where they have these futuristic societies or civilizations where they've essentially harmoniously integrated these ways of being that don't affect the environment. They don't affect their world, and they've just symbiotically, connected to nature itself, where their homes are just a blend in nature versus us having to chop down nature in order to make a home out of the destruction and rubble that we've kind of created on the world.
For sure. Yeah. I mean, imagine a home where the walls are literally made of the same material as the forest, right? They're part of the mycelium. Yeah. They're part of that ecosystem. The roots would form a thatch over your roof. And let's say you had baseball-sized hail that punched a hole through it. It would heal itself because it's a living organism. Natural. It's not and it's not something that you would have to constantly buy materials. It would have the ability to do it themselves. Some of the more technological advancements as far as that goes right now are dealing with metal. I got 2 videos here on self-healing metal. Again, I mentioned in the intro, airplanes, if you were to, let's say, take a hole through a wing, would it have the ability to repair itself? Even for military applications, things like that, vests, armored vehicles,
astronauts, right? Astronauts in spaceships that are
exactly. Yeah. Even our satellites, right? If we catch a piece of space junk going at 70,000 miles an hour, a bolt is going to go right through the ISS without too much issue. Right. So this is a big one when it comes to metals. Let's take a look and then I'll get your thoughts.
A metal that can heal itself has been discovered by scientists. During an experiment, they observed that pieces of metal spontaneously crack and then fuse back together without any human intervention. This newfound phenomenon has the potential to revolutionize engineering, opening the door to applications such as self-healing engines, bridges, and airplanes. The scientists had been attempting to evaluate how cracks formed and spread across a piece of platinum. To observe this, the scientists used machinery that pulled the metal's ends 200 times per second. They were stunned to watch the cracks heal themselves in real time. Repeated motions can often cause something known as fatigue damage on machines. This damage leads to cracks, which expand over time and can eventually end a machine's working life. This self-healing property in metals could offer a solution to these issues. However, the newly discovered mechanism only works on a few metals and on incredibly small scales, at least for now. Further research is needed to fully understand and harness this phenomenon, including whether it can be induced in conventional metals outside of a vacuum environment. The implications of such a breakthrough could be far-reaching, benefiting industries and economies worldwide.
You want to take it to the next level? You guys remember Terminator? And the Terminator, there's this robot or whatever that essentially is like a liquid metal. We've actually talked about this on an earlier episode, where there's this liquid transforming metal that can reshape itself into a physical solid matter form. But in the movie, The Terminator, there is a robot that's highly advanced, intelligent. It's super intelligent. It's a fighting machine and a war machine, and it can morph its body into literally any shape and person, by the way. Now we're talking totally science fiction, but everything is science fiction until eventually becomes science fact. Yeah. And the fact that we're working on these materials now, and we have been, by the way, for decades, the nanotechnology that has been talked about since the 90s, actually, and in real applications, it's very difficult to get these things into practice, into larger scale practices. But I feel like human beings, like we somehow like accelerate our technological advancements like so fast. It's just you get whiplash. So I think it's going to be, I don't think it's going to be that much longer. I really don't. So.
Yeah. And I got one more here on metal, and then we'll get into things like aircraft skins and things like that. And even some UFO metamaterials that we are rumored to be in possession of, physical UFO artifacts displaying crazy properties, weird layers, no apparent purpose or use for such a material, extremely high cost, and at a precision level that we supposedly can't even make it ourselves. That'll be a little bit later on today's show, but let's take a look at part 2 of healing metal.
You can see it's actually a really shiny metal, but that doesn't last forever. It doesn't take long for that shiny surface to become dull in appearance. That's because the metal is reacting with oxygen in the air. Actually, the same thing happens when you cut any metal. It's just that oxidation layer isn't as visible in the case of, say, steel as compared to sodium. So it's understandable then that if you took 2 pieces of metal and pushed them together, they wouldn't form one single piece of metal because there is a layer of oxidized metal in between. In fact, if you were to cut a piece of metal in the vacuum of space and then push those cut surfaces together, they would fuse together. We know this because it's happened in situations when we don't want it to happen at least once. In April 1991, the Galileo spacecraft was supposed to open its high-gain antenna. Looks a bit like an umbrella, but 3 ribs of that umbrella had cold welded to the body of the spacecraft, and so it couldn't open. This stuff is a bit different to a metal, though, because it's a polymer, so it would be more like if I cut a piece of plastic into 2 pieces and then try to push those 2 pieces together. In this case, clearly, they don't fuse back together. And I suppose that makes sense. Like, if you're cutting a piece of plastic in 2, then you're cutting through individual polymer chains. You're breaking bonds between carbon atoms. When you break a covalent bond like this, you're left with radicals. That's atoms that have unpaired valence electrons. They're incredibly reactive, so we should expect the exposed surface atoms to react with molecules in the atmosphere, or if it was in a vacuum, I imagine they would react with the atoms around them in the substance itself. And so that exposed surface becomes unreactive. It's not sticky anymore. If you press those 2 surfaces together, those bonds aren't going to reform unless you can introduce quite a high activation energy. So why is it then that I can cut this material into 2 pieces, push the 2 pieces together, and it reforms into a single piece? Well, the full explanation, it seems, is hidden behind trade secrets, but there is some information out there. I want to announce this Patreon exclusive live Q&A I'm doing on Monday, the 20th of June, but I don't know where to put it in the video. Put it anywhere. Okay, thanks, Patrick. Not all self-healing polymers are the same.
So, self-healing material, again, I got to go back to sci-fi. Just because I think about like Star Trek, which we've all seen, where or even the Iron Man movies, which Iron Man has like this nano suits that can essentially heal or transform into different forms as he needs it. Now those are like completely unrealistic ways to use some of this material. But you mentioned earlier about computer screens. This is or even cell phones, which are probably the most used device in the entire freaking world, is a cell phone. Billions of them exist in this world. But if you could have a cell phone screen that when you drop it, instead of having to worry about something happening to it, it just heals itself. I mean, come on, that would be like the most sought after material. The whole thing, in my opinion, is getting it into production and also making it cheap enough for like the average consumer. I would love to know about how we're going to do that. I don't know how we're going to do that. I just know that eventually everything becomes so cheap that it's affordable for everyone. Those are the kind of things I think would be great. Now, I will also say, I don't foresee any near future where they're going to give us self-healing anything, because then they would lose the whole market of having to repair stuff, which is kind of like the hold that Apple has on people, in their devices, computers and phones and everything. Apple devices, when you break them, they cost hundreds of dollars to fix. Hundreds. You think they're really going to get rid of that whole market? I highly doubt it. Not anytime soon, unless they can find something else to sell us that will replace that market.
Yeah,
So,
and I would argue that they haven't been building products to be easily repaired. They've been building products to be thrown out and replaced. That's why
Yeah.
you got to come buy a new one. They build in this obsolescence in everything, where that at some point it becomes cost ineffective to even fix a damn thing. You want to fix a 10-year-old TV, the amount it's going to cost you to fix it, you could buy a new one. That is by design, is what I'm saying, because it shouldn't be like that. And in fact, there are even governments around the world lobbying these companies to say, hey, if you don't offer realistic parts at a reasonable price and repair centers that people can take these products to be fixed, like with appliances and TVs and all that, if you don't want to go that route, then we're just going to block your products from being sold. Now, in North America, that's not the case because it's a massive business, but I can see that potentially going somewhere in the future if people made enough noise. And a big thing too we're dealing with now with energy and batteries, and all of our devices rely on power, and we don't always want to be plugged in the wall. So battery tech is a big thing, not only for electric cars, but just transportation, automation, home electronics, personal devices, all that type of stuff. And they're using these things called solid state sodium batteries. So they're basically made of materials that are far more abundant than lithium ion. And right now it's proven difficult for mass production. But effectively, if we could switch from conventional lithium-ion batteries, which are in our phones, electric cars, so we could somehow get that to solid-state sodium, it would be both cheaper and safer. You wouldn't have the fires. And a team from Osaka Metropolitan University in Japan claimed that their newly discovered process could overcome that obstacle. And basically, it's useful for production of almost all sodium-containing sulfide materials, solid electrolytes, and electrode active materials. So that's interesting coming in down the road. Some of the things I found the craziest was in regards to fluids and how they can change fluids behavior. And here's one here. It's a laser hydrogel. So it makes this, it almost looks like an Air Jordan, or kind of like what used to be in the record back in the day. If you played like a 45 over a regular LP, you had this little spacer that would clip into it. But that is called kirigami. So basically, new options for making finely structured, soft, flexible, and expandable materials. So essentially, when they hit them with a laser, so they use laser processing to cut structures in the film, and then they would add water, which would cause it to swell. And then the patterns would work in such a way that the width would increase when stretched lengthwise. And it's also called the ossetic property of this technology. So basically, it behaves differently when a laser is added or when moisture is added, either direction. This one is the coolest of all. This is an interdimensional superfluid. Behaves differently based on what dimension it perceives its world in. So it's an international research team from Innsbruck and Geneva, for the first time, has probed the dimensional crossover of ultra-cold quantum matter. So in the regime between 1 and 2 dimensions, quantum particles perceive their world as either being 1D or 2D, depending on the length of scale in which they're probed. So for a short distance of probing, they refer to that as 1D, but 2D is what it would be for long distance. So it actually behaves differently based on what dimension in space it's programmed to occupy. I mean, that's UFO tech right there, man.
Yeah.
Behave differently in a different dimension.
Listen, this is my opportunity. I've been waiting for this moment for all day long. Okay, just to be honest, everyone, stop what you're doing right now. Not right now, but like in life, and watch the 3-Body Problem on Netflix or read the book, because one day we're gonna have a conversation about that here on the show. There's so much science involved in that TV show. It's not even funny. Long story short, there's an alien race that talks about multi-dimension, like using energy from multiple dimensions, and how we can't even imagine being able to, for example, create a supercomputer that is the size of a proton, but that can consume the entire world with its technology and reduce itself back into that size of a proton again, pulling energy from other dimensions that the energy that is so vast that, again, it could power pretty much anything you can imagine. Now, if we can do stuff like that, we can do anything even remotely close to that. If there is an alien race out there that's doing that, then the idea that they're using smaller devices or whatever to pull energy from another dimension, I mean, that kind of solves the problem of how are they able to do what they do, right? How can they use so much energy? They should be using so much more energy, They don't need to if they're pulling that energy from other dimensions. And again, if we're doing that, that's pretty awesome too. But I won't get too into that because that's a whole nother episode. That's more speculation than anything.
Yeah, and we do have some UFO clips from TTSA and our friend George Knapp coming up in the second half. But just while we're on the topic of changing state, new, quantum materials behaving differently based on state, here's an example. So they've observed a quantum effect called hybrid topology in crystalline material. So it opens up a whole new range of possibilities for development of efficient materials and technologies for science and engineering. But basically, this liquid behaves a certain way based on the quantum information within it. So it doesn't really, it's like potential energy can become whatever it's intended to become. These are sort of like blank slate materials that when given, a purpose or assigned a value will behave differently. So it's like a generic material that can be just about anything. You could basically make many things out of one material because it's the quantum assembly of the ingredients. So it's not like you made aluminum and now you're trying to find all the things you can use aluminum for. You could assemble many different elements into many different alloys or, materials to make just about anything. So it's like 3D printing at the quantum level, where we mentioned this on previous episodes, where we're going to get to the point where we can literally design everything particle by particle from a recipe. You want to bake cookies, you want to bake bread. All recipes are similar, but totally different outcome. We're going to get that specific with what this technology looks like. And so they call them hybridides. So there's two main types of these quantum states, quantum edge states and quantum surface states. So you can see here along the edge, kind of that dinosaur spine, stegosaurus look. And then the quantum centers behave differently as well. That's important because of their various properties, but they never behave simultaneously in the same way. They always mix to form a new type of matter. So that's totally unprecedented. We've never seen anything like that before. And, while we're on the liquids, I got a video on liquids and then we'll move into something else. So let's get rid of our intelligent liquids topic. We'll scratch that off the itinerary and we'll keep it rolling.
Harvard scientists have developed an intelligent liquid. As soon as I saw this, the first thing that popped into my head was water elemental from D&D, or maybe natural evil water from One Punch Man, if you're familiar with the manga. Well, unfortunately, we did not make sentient water. It's not actually intelligent like an AI. It's not making decisions or doing things, but rather, instead of making a metamaterial, we made an adaptable meta-liquid that can change its optical properties. It can change from Newtonian to non-Newtonian, its pressure, a lot of very interesting things. So the real story is both more complex and less complex than some of the magic stuff. So let's go ahead and jump right in. And I want to give you a TLDR of what a metafluid is. A metafluid is a fluid whose properties can be derived from its structure rather than what it's composed of. And the same is true of a metamaterial. You've probably heard of metamaterials. They put interesting things inside of a material to give it a new structure and thus new properties. Well, scientists at Harvard wanted to do the same thing with liquid. And if you look on here, you see these almost square snakeskin-like little beads on the image. These are actually tiny little air bubbles, 50 to 500 microns, just filled with air in a malleable container embedded in silicon oil. And the reason for this is that the air bubbles that are inside of the oil actually give it a new and interesting structure and allow it to do different cool stuff. Now we're into the more scientific part of it. As you change the pressure to either expand or condense the little orbs, the liquid's properties, including its viscosity and opacity, changes, which is very, very interesting. It can have less liquid friction or more, and because this is very variable, you can actually use a robotic gripper to pick up small and delicate objects without needing a sensor. Typically on a robotic arm, you would have a sensor that senses pressure so it doesn't crush the thing it's picking up. In this case, all of that's handled quite naturally by the liquid and never crushes the object, which seemingly is intelligent, but it's really just really good design. As the silicon oil either expands or contracts under pressure, those little air bubble pockets can get crushed down to being non-existent, which actually changes the optical properties of the water. When the pressure is low and the capsules are round, they scatter light, a lot like air bubbles, but when they're compressed, they allow a lot of light to pass through. This liquid can also change from Newtonian to non-Newtonian, which is like a totally different fun thing. We're actually going to go ahead and briefly play they're not even showing off. Yeah, there's the opacity thing. It doesn't look very cool here because they're measuring it in the millimeter scale. Definitely not the most fun video to show off. Whoever took this photo is on point. So this is a very cool thing. It has a ton of practical applications from both robotics, especially robotics around sensitive materials, to honestly, all sorts of optics, of manufacturing and construction equipment. There's just a lot of cool things you can do with this.
Yeah, that's actually really interesting. So the way that I've made sense of this, and I'm not gonna try to use all the jargon. He uses a lot of jargon that a lot of people don't know about, but essentially it like they call it dynamic reconfiguration. So it changes based off of, as he mentioned, not necessarily like you make a material and it's stuck at that material. And you talked about this earlier about the idea of a material, the same material being able to be applied in different applications based off of the need itself. There's a lot that you can imagine with that. I mean, there's a lot. Sure. There's just use your imagination, name anything that you can think of, and it could be used for that. But it could also change. It could change and reconfigure to change to be used for other things as well. So there is a lot. I mean, he mentioned that it can be used to improve optics. It could be used for, I don't know, like through electromagnetic manipulation. By the way, that's how it's manipulated, is these electromagnetic waves that or light that controls the electromagnetic waves. I'm not sure how all that works. I'm not scientific enough, minded enough to really go into the details of that, but I do just think of it as a small electrical charge or a specific charge that can manipulate the type of structure or the type of application for that structure. Yeah, that's how I conceive of it.
This might explain it a little better. They're dealing the same thing with lasers. So they're, quantum behavior at room temperature, when laser light makes things magnetic. As we know, a lot of the superconductors and things that we need are all at extremely cold temperatures. So there's still we have yet to discover a viable room temperature semiconductor. So making something magnetic with a laser doesn't really involve the temperature extremes, but the potential of this is massive. So Stockholm University and the Nordic Institute of Theoretical Physics have succeeded in demonstrating for the first time how laser light can induce quantum behavior at room temperature and make non-magnetic materials magnetic. And that's essentially what we're talking about with those superfluids, things that he mentioned, Newtonian and non-Newtonian. If you want an example of a non-Newtonian fluid, You can take equal parts of cornstarch and water, mix it together. I forget what it's called, but kids do it as an experiment. So you make this like slime you can make it into a ball, but as soon as you let go, it just runs like water. But then you grab it again and it goes hard and then it relaxes. I think it has to do with the gluten structure or something like that.
We just did this a few months ago. I don't even remember. It's
called
really
oobleck, I think is what it's
really
called.
cool. It's really cool.
But that's an example of a non-Newtonian fluid that we even use just for like kid science experiments and things like that. So a lot of this seems far out there. It's not. We've had it for a long time. We're just now, it's almost like 20 years ago in a lab, scientists witnessed stuff. They're like, wow, that's kind of cool. But what do you do with that? Like nothing else is caught up. We can't use this in a broad application. So let's just kind of put it on the back shelf for the day that it's a little more realistic. Well, that day is now coming around. They can now go back to these things and look at them and understand why is that actually happening? Can we apply this to technology, health, science? We mentioned medicine and things like that, targeted drug delivery. I couldn't find the image at the time, but here's what it looks like. So they implant a molecular device and self-healing materials that can fix DNA and sort of kill disease on the fly. Again, there's ethical implications anytime you put something in your body that has the ability to make decisions without, human interference. But basically, they observe that an injured or damaged site, the component will trigger the release of functional molecules, kind of like little medicines or healing agents. They precisely target the area in need, like a tumor. And this basically holds promise for things like self-healing materials. They can repair themselves in situations, prolonging lifespans, and even not in the human body, but things like we mentioned before, cell phone screens, things like that. So there's a lot of applications there. And even in terms of like electricity and power, we know hydrogen is getting more and more popular in the world of alternative fuels and things like that. But again, producing it is one thing, storing it is another. A firm in Japan has started a metal-based hydrogen carrier that can actually multiply the amount of hydrogen. So you would put in X volume and you would get out Y volume. But the issue with that is that it's magnesium hydride is the element used for that. Is it safe? But so far, no. It's violently explosive and not feasible. But it does multiply hydrogen concentrations, which is cool in itself. So all these technologies are at varying stages of infancy. Some of them are just getting started. Some of them we've been playing with for a while, and some of them we won't have the tech or the computing power to even go there. But with AI and the advancements of quantum computing, a lot of these things, we will develop things and invent things that a human would not even have to think of. Things so complicated that only a computer could figure out. Well, that's right over the horizon next. Again, is that good? Is that bad? We could argue the ethics of that all day long, but it's happening. So it's important that everybody needs to know. So we want to bring it to your attention. That's the whole purpose of the show, is to take you down a rabbit hole of a topic you wouldn't normally be researching, but in a small enough junket, you can leave with more information than the average person on the subject. And maybe it gets you inspired to do a little more research if it's something you like. So in the second half, we're going to get into the world of metamaterials, UFO tech, bits of, recovered spacecraft, according to some very high known and very well respected people. This isn't just the tinfoil hat wearing ufologist, as we're so lovingly referred to sometimes. These are people with real reputations, real credentials saying this is real. We don't know how it works. And we couldn't even make it if we wanted to. So very fascinating stuff. We're going to get into that in the second half. Marquise, anything before we go to our second half here, brother?
Yeah, I only want to say, like, we are approaching some topics that I've never ever engaged before, and this is actually awesome because a lot of the things that we're learning, I'm literally learning them along with everyone else. So if you are, and I know that I think there was somebody here before in the comment section, a couple of videos before, if you know anything about some of the stuff we're talking about, by all means, if you're in the chat, post it. But also, if you're listening after the fact, post some of the stuff you know. Give us even references or maybe a documentary or video, something that can inspire each of us to kind of learn more about this and, imagine what the future could be like, even sci-fi. If you know a sci-fi episode from a TV show, listen, I'll watch it, especially me. So just to inspire some of these thoughts, to expand our consciousness, because again, we are, at least for me, I am learning for the first time a lot of these topics. We've gone through so many things we've been interested in that we're approaching things I personally have never even thought of, or even read about. So
And shout out to our friend and Patreon Quantum Club member, Scott Rosa. And he provided a lot of the articles for us to kind of get our brains into these topics. I said, Scott, our next episode is going to be material science. He's like, I'm on it. And
he
like
was
30
on
videos
it.
and clips and everything.
God.
So,
Scott,
if you are a professional or expert in any of these fields, please get out with us. Like, get in touch. We want to put out correct information. If you can add some, clarity to a lot of confusion that we have to sort through in the process of doing our research, it's more than welcome. We'd love to have your input. But shouts out to our buddy Scott Rosen and everybody else. Check out our Quantum Club. The link is in the description. You can join for free. It's another 30 episodes that aren't available on our regular platforms. In some cases, we can be a little more candid and give our full opinions without censorship. So if you like the topics we cover and you want to sort of get a behind-the-scenes look of what went into the show and some additional topic extensions that we didn't get into during the episodes, check out Quantum Ladder's Quantum Club. Again, links in the description, and you can join for free. So we'll take our halfway point break. Everybody get a refill. I'm drinking water today. You got your water, Marquise?
I do have my water, but it's just out of reach right now. It's literally just out of reach.
Well, we'll go grab some more refills. Anybody else having a cold one, have a cold one for us. We'll see you back here in 5. And welcome back to the second half of Quantum Ladder Podcast. Today we are discussing cool material science, and hopefully Marquise unmutes his mic before we get going here because he's a big fan of the mute button. There we go.
It's not that I'm a fan. It's a habit because when we do the break, it doesn't automatically mute. It only mutes whenever we have the videos playing.
Yeah.
So yeah, it's a habit. I'm gonna break that.
That's all good. It's all good. We just like hearing your beautiful voice, my friend.
Yeah.
It's kind of hard to do a podcast with no audio.
It's a little bit hard, a little difficult. It can be done. You just look around and people do it. There's a guy who literally does a whole channel where all he doesn't speak at all. He just gestures, and he's got millions of views. So, I don't know how that happens, but that's not us.
Maybe we're doing something wrong. Maybe we should just do a sign language channel. There you go.
What's the guy's name? Abi. What he literally he'll show a video of somebody doing something ridiculous, and then he does a gesture where he emulates what they should have done, and then does you guys know in the chat, you know what I'm talking about. He's hilarious. I think he's like South African or something like that. Real tall, skinny black dude, and he always he just that's all he does. Doesn't talk, never talks.
So before the break, we were talking about metamaterials, and metamaterials are a scientific term, but they're also existent in the UFO field. As soon as people hear metamaterials, they start thinking about people like Hal Puthoff or arts parts, or even bits of metal that To the Stars Academy had analyzed. We've got some video clips on all that. But first, let's explain what metamaterials are, and then let's talk about some interesting metamaterials that some people are in possession of.
Metamaterials are artificial materials designed to provide properties that may not be readily available in nature. The impact of metamaterials could be enormous, since its properties can be tailored and manipulated. Significant reductions in the size and weight of components, devices, and systems, along with improvements in their performance, seem achievable. Comment what you think so far and share for part 3 about the applicability.
All right. And then UFO metamaterials.
Part 1.
A global scramble is underway to identify and perhaps replicate unidentified mystery material that's been collected in multiple sites around the world.
A few of the samples have defied analysis by leading scientists who say they don't know how the material was engineered or why or by whom.
Now, some of this metamaterial was allegedly collected in connection with UFO incidents, which gives the whole endeavor another worldly glow. The I-Team's George Knapp has the story and the Las Vegas connection.
The whole fleet of them look on the ASA. For years, the Pentagon secretly studied the seemingly impossible abilities of unknown craft captured in these military videos. Scientists now want to know if the materials used in these mystery aircraft allow them to do what they do. For years, one of the secret studies was carried out by BASS, a Las Vegas operation hidden within Bigelow Aerospace. Documents first reported by the I-Team show that BASS landed a contract with the DIA.
Part 2.
One of the objectives was to study so-called metamaterials, as well as futuristic technologies.
It was a multi-layered bismuth and magnesium sample. Bismuth layers less than a human hair. Magnesium samples about 10 times the size of a human hair. Supposedly picked up in the crash retrieval of an advanced aerospace vehicle. Looks like it's been in a crash.
In Las Vegas back in June, physicist Hal Puthoff came pretty close to saying that this weird wedge of metamaterial came from a crashed saucer, but he can't know for sure. Puthoff and his colleague Dr. Eric Davis are on the cutting edge of attempts to identify an assortment of bits and pieces that are seemingly beyond anything we can create. This one sample is engineered in layers thinner than microns through a process unknown on Earth, and for a purpose we can only guess.
So, I don't know if you've seen I don't know how many times you've seen the documentary, The Phenomenon, James Fox's documentary. I've watched it a few times. Probably one of the most important documentaries of all time when it comes to this field and the science behind it. There's a scene in that documentary where Gary Nolan and Jacques Vallée have a conversation, and I've been talking about this for a while. Not anymore, but I mean, when I was, when we were in it, I was talking about this a lot. Gary Nolan and Jacques Vallée have a conversation about how they tested some metamaterial that had these interesting isotopic ratios in them that kind of told them a lot about the material itself. Not necessarily origin, but at least they kind of determined that it wasn't made on Earth, that the material itself couldn't have been made on Earth. As a matter of fact, they determined based off of the material science that it couldn't have been made in our solar system, which is very interesting because the isotopic ratios were just different. I guess they were the way that our solar system works. And this is, again, you guys can correct me. You science guys can correct me. Maybe you can, because you probably had a lot of connections and direct conversation with some of these guys about this. But that the isotopic ratios were not, they were not akin to anything in the entire solar system. Within our solar system, the isotopic ratios with certain materials are consistent throughout the solar system, which means whatever this stuff wasn't made here, wasn't made on Earth, wasn't made on Mars, wasn't made on the moon. It was made somewhere like way out there. Who knows?
Yeah.
I think that's fascinating. I
was fortunate enough to chat with Dr. Gary Nolan about 2.5 years ago about those very parts. At that time, he hadn't spoken as openly as he has in recent years. And I knew that he was somebody who knew something, and I wanted to do my best to try to pick his mind and get something out of him. So I started describing that exact piece of metal that George Knapp and Hal Puthoff were talking about. I said, it was back in the day, it was referred to as arts parts, and Linda Moulton Howe got a piece of it. And then Hal Puthoff got a piece of it to the Stars Academy with Tom DeLonge. And as I'm talking, he kind of reaches off camera. And the whole time I'm talking, he's not in frame. And finally, I run out of things to say. And I'm like, you better be grabbing a piece of that, because I don't know what the hell's happening right now. And sure enough, he grabs a little piece of it. This is a rock that my daughter brought down here for good luck. And holds a little piece of this stuff right up to the camera. And I'm like, yeah, that's the stuff, the bismuth magnesium layer. Like, how does that even work? And then he gave a little and then took a little back. And I said, isotopic ratio is the same thing. He goes, well, there are ways to rearrange isotopic ratios. I'm like, yeah, in a particle accelerator. And he goes, well, fair point. Right. So he didn't want to put so much emphasis on it because of where he was at the time of his own disclosure. But effectively, the only proponents against that piece of metal say, it's slag from a smelting plant, hence the layers. I don't believe slag at a smelting plant produces layers smaller than a micron. They are visible with the naked eye. Things at 1 micron or less are not. And, if you look at how that would be made, why would you make it? There are other ways to make material as light or layered materials. But, some people even propose that piece of metal has a waveform, and that's precisely how the craft behaves. Yeah. It's from the skin of the craft being made out of crazy metamaterials like that. And in fact, TTSA has now been abbreviated to TTS, effectively Tom DeLonge, Jim Semivan, Hal Puthoff, a few other players. But they actually did a little video. It's a 3-minute clip on TTSA and what input they can give on exactly what George Knapp was talking about. So here it is.
Well, when I reflect upon what we've been able to accomplish, I sit here and kind of go, yay and hey. Because the expectations are huge. When the expectations are extremely high, performance has to follow. And so performing is key to me now.
We have multiple samples now from multiple sources, ranging a wide variety of integrity. Even if the material goes nowhere, people are beginning to provide us things.
Wow, that is more brilliant than I thought.
What's different about the activity that we have going versus, quote, the field out there, is that the field out there is really filled with people who have opinions and thoughts and beliefs about what all this kind of stuff means and so on. But TTSA has been put together on the basis of the mantra, you might say, let's just follow the data and see where it goes.
It is a bit like a fine art dealer, right? You're always looking for that lost Picasso. Chances are everybody comes to you and says, I have a lost Picasso, and it's probably someone's finger painting that they did in high school. But occasionally and rarely, and it only takes one time, you find that Picasso locked away in someone's attic or someone's basement and they didn't know they had it.
My whole career was about solving really hard problems. This is a hard problem from so many different directions. It's technically not understood, socially not understood. And so we're on an inflection point now of an opportunity to do something really, really, really different.
And so I think that that's why we have a chance of actually making real progress, because we will follow where the data leads us.
I want to make sure that I have a healthy dose of skepticism to make sure I'm not blindly accepting something because it's cool or neat or new or something like that. That the data supports the decisions that we make, the dots that we connect, the moves that we make. But I see a diligence being applied to this that gives me optimism that we stand a chance of being able to make some real progress here.
I think we may cautiously optimistic be, on the brink of something really new.
We have to do this the right way, and the right way isn't necessarily the right now way. We may just be at the beginning of the headwaters. Maybe we're just in a stream right now, and we're just at the very beginning, and it's just a small creek. But I think eventually that waterfall will come.
So the first thing that there's a lot. I'm going to try to. I don't want to mix too much of why we left ufology into this comment here. But I wrote down a couple things while they were talking. There was a point that I got to when they were talking about what it would require for someone to make some of this metamaterial, and I want you to think about this. Imagine that you're a scientist, okay, and you found somebody has sent you a material, and you have looked at this material, you've studied it, you've used these microscopes that can look into the whole atomic structure of a thing. And you determine, you along with other scientists have determined that in order for this material to even be created, it would take a planet-wide operation to do the project. Not only that, but it would require the power of the sun or a Dyson sphere to be able to even create a usable amount of this material, okay? You would not stop and say to yourself, well, you know what? I think we did it. Because that would be ridiculous. It would be ridiculous. It would be, and not to be rude, it would be kind of unintelligent to say, something that a scientist or a group of scientists clearly have determined would require, again, a planet-wide cooperative project to execute. And it just doesn't make sense to me. It does. I can't imagine that it's human-made. So whatever this stuff is, they haven't come to the conclusion that it's not human just because they want to believe it. The science is telling them that there's something about the material that clearly indicates that we didn't make this stuff. Maybe we have taken some of it and found a way to reverse engineer a portion of it, which has been said by people in the field, but to completely recreate some of this material that, again, has been stated by scientists to have been would require an amount of energy that we just don't have. We don't have that. It doesn't make sense. It's unfortunately it's not very well thought out. Those ideas aren't thought out,
especially with the whole isotopic ratio, not being in a pattern that even exists on our planet or our solar system. You can't and we don't just get in the habit of rearranging atoms and structures of carbon and things like that just for fun, because of the vast amounts of energy and money and all that involved. Yeah. So if this is just a piece of metal from something that's used for technology, why would you spend so much money to make something so labor intensive? There are lighter materials. There are faster to make, cheaper to make. What purpose would you have in making something that complicated? Others say that it's military and we just don't know about it because it's military. I have a video here on Lockheed Martin and their aircraft skin, kind of like a UFO shell for airplanes. So if we think the military doesn't have their hands all over this stuff, or isn't extremely interested at the possibility of how do we make this ourselves, what kind of advantages could we glean, we would be foolish in thinking that this isn't just for the UFO community. This is actually happening. This is the topic of DARPA contests, classified meetings, and all kinds of hidden science tech from the biggest aviation companies that we will never know of because of the highest level of classifications are being attached to these things. But let's check out aircraft skin from Lockheed Martin.
We'll be able to grow or make a structure that, say, is the skin of an aircraft. That.
And no idea why there's no audio on that one. Apologies for that.
I could hear the audio. I heard the audio.
And there's no audio from our keys either.
Wait.
All right, apologies for that. We should be good to go.
We'll be able to grow or make a structure that, say, is the skin of an aircraft, that inside of that is also contained the sensors or the energy storage or many different multiple functions.
New materials that are on the lab bench right now, they can literally change shape on command. They can become almost a muscular material.
We could have an airplane that optimizes its shape for the different flight conditions.
I mean, that's UFO tech right there.
I got a joke for you guys. You guys ready? This is great. This is an awesome moment. I'm so happy about it. I love these. This is great. So there's a joke, okay? And I think it is so relevant to this moment right now. Kind of. The joke goes something like this. Excuse me for not being perfect with it, because I just heard this joke today. Albert Einstein, he dies. Okay, he dies from some tragic accident. He goes to heaven, and he's greeted by the angels. And the angels, they approach him and they welcome him and they give him this, grand welcome. And he's just happy to be there in heaven with, God and the angels. And then he stops and he thinks to himself, hey, listen, I want to play the violin, because he loves to play the violin in this scenario, this joke. And the angels warn him, don't do that, because God doesn't like the violin. Doesn't like the only thing that plays in heaven are trumpets. And so Einstein, he's upset about this because he loves the violin. He loves to play music. So he's thinking to himself, oh man, this isn't great at all. As a matter of fact, now heaven, in this sense, becomes his hell, because he can't do the one thing that he loves the most. He loved the most in life, which was play music, not just mathematics, but music. And so in the moment that he thinks this, he hears trumpets playing music in heaven. Okay. And we're at this point assuming according to the angels and the situation that God is playing these trumpets, this music, God himself. And so Einstein gets the bright idea, you know what? I'm just going to play, because I think that God's going to love me playing this music with him. I'm going to play this violin with God, and it's going to be beautiful in heaven. And so he pulls out his violin. He starts playing the violin. All right. And all of a sudden, the music, the trumpets, they stop. And it's ominous at this point. Something doesn't feel right. And everyone in heaven, everything stops. The angels stop, and God appears before Einstein and kicks him right in the balls. All right. Crushes his nuts. So Einstein's on the ground, rolling around, nuts crushed. God standing over top of him and says, I hate violins. We only play trumpets in heaven. And disappears. And Einstein's left there just totally in pain. Now he's got to live all of eternity with crushed nuts and no music. Now it's become truly his hell. And the angels come to him and they say, well, we warned you not to play with God. Now, I learned this joke from a movie about a super advanced intelligent alien race that we're trying to match technology with. You should never play with God. And the reason why I mentioned that, this joke, in reference to what we're talking about now, is because we may think we can match their technology, but we can't. We can't even imagine how they've done what they've done. We may be able to derive some things from their technology, just as it is Einstein playing the violin. It's music, but it's nothing like what God does. And so, no, the aliens are not gods, or whatever these non-human intelligences, whatever they are, whoever they are, they're not gods. But whatever they are, they're so far advanced from us, they might as well be like gods. And for us to have the hubris to think that we can make a certain material out of it, but we don't have any idea how it works or why it even does what it does. Not the core true, the true purpose of it even. Why do they do this? That's hubris. And that is playing, in my opinion, with God, at least in reference to the joke that I just made. It's a dangerous game. We got to be careful, because we don't know how they've done what they've done. We don't know what they're doing. We don't even know what their civilization is like. Are they us? Are they us from the future? Are they interdimensionals? Are they hyperdimensional? Are they from a multiverse? Are they from another solar system? We don't even know. But somehow we think that because we can make maybe a morphing skin, or we make maybe we even make a craft that can do some pretty amazing things. We think we know, the mind of God. We got to be careful with that one. I think we should be very careful.
Yeah, for sure. Just because we can come close or emulate certain parts doesn't mean we have the faculties, right? I mean, if I give my daughter a picture of a kitty cat and say paint it, she's going to paint what she thinks looks like a cat, and it will be total nonsense to anybody with an adult mind as to that's a cat, like looks nothing like it. I think we are on that juvenile level. Again, nobody's right, nobody's wrong, because nobody knows. But to just throw it all out and say, it's all nonsense, be careful. You don't want to play because you don't know that again, you make a whole bunch of noise in the woods if you don't know who's there. So it's best to have some humility about some of these topics. And I found a video about sort of a new world reimagined, and not 1,000 years from now, but like 5 or 6 years from now. What does 2030 look like? And it's crazier than we thought, even in 2020, that 10 years from then, we would have all these crazy new things. So here's a kind of a concept about a world reimagined in as little as 5 or 6 years.
New connectivity, new computing, new platform, new ecosystem. These build the foundation of the Intelligent World 2030. Enable ubiquitous connectivity and all domain perception. New computing, from silicon computing to optical computing and quantum computing, from all-flash to DNA storage. An open computing ecosystem enables pervasive intelligence. New platform. The ongoing accumulation of industry experience into a converged digital platform, which can be inherited, ultimately enabling digital innovation in all industries. Welcome to the Intelligent World 2030. Intelligent, green, and inhuman insight with robotics, AI, and more. Becomes a key factor in production. People's focus shifts beyond material wealth, and digital means achieve digital equity and fairness, as well as taking control of the metabolism, the very health of the earth.
You ever hear of the Internet of Things before, the IoT? Okay, so in case anybody hasn't heard of it, let's just for a moment, because this is what my mind goes immediately to that. I remember hearing about it like 7 years ago. Like 5G and the Internet of Things were going to be like the new thing in like 10 years or whatever the time frame would be at this point. I don't know. This is irrespective of like AI and stuff like that. But there is imagine like every single thing, physical objects, are connected to the internet and sharing information between them to give you real-time information about different things for different purposes. Example, the ground itself could be connected to the internet. And as cars are driving over it, it could send information to your phone or your smartwatch or smart glasses, which are here now, or whatever AI device you come out with, like the AI pin or whatever. It can send that information to you to say, hey, you're walking down, Main Street, but there's a traffic jam right now that just happened because an accident went down. And so you need to divert your route to this direction, or you're driving and it does the same thing. That information is interesting. It's good. But what about like if you're at home and you need that information for like I mentioned this before, you have a smart home. You walk into your home has got cameras on it, of course, because now everybody has cameras, home cameras, security cameras for the most part. And it can determine that, hey, listen, you're low on, I don't know, you have an iron deficiency for today, or you need to drink some orange juice, or you need to take your insulin, or you need to, I don't know, whatever. You go use a bathroom and it says, hey, you have these issues right now. You need to eat this kind of food and you have to have these many carbohydrates because there's something in your urine. This is the kind of thing that you can imagine. And we're talking real near future. Maybe not the smart home thing yet, but in other ways where there's information being shared from objects within, like all over the place, all kinds of objects. And it's super, super cheap. Like like they build things at the dollar to sell at the dollar store. Imagine devices being that cheap to put those kinds of information processing in them. The little chips that can share that information, can be connected to the internet to give you information about them. That is the Internet of Things. I can't begin to tell you. There's a whole episode we can do on the Internet of Things.
Yeah.
But that's what I see when I think of that, or
and we probably will at some point. I saw something cool the other day, not so much sort of the internet connectivity, but in terms of somewhere in Europe where they're very much into electric cars, they're building roadways that will receive information from the cars, tire pressures, charging status, and you can even recharge the car. So you don't have to worry about recharging as you go. This is like you're grounded to the road. That's good enough. I mean, all you need for a wireless charger, your phone has to touch it. Basically the same thing, where the road in itself would charge the car. Therefore, you would have as much range as the electrified road would give you, or even sections of road that, you know, for half an hour on your trip, it's going to give you enough juice to recharge your car. You wouldn't have to make the whole highway. Just maybe every 10 miles or so, you'd have a little charging strip. That would be, if you needed to top up, you would get it. It would know your destination based on your GPS. It would know that you don't have enough to get there. It would just do it automatically for you. And that's just one tiny example. But to your point, Marquise, you could have a home where you go in, you urinate, it realizes that, hey, you've got some weird protein in your urine. That could be a sign of early kidney problems. Go get that checked out. Here's one of 3 things it could be. Here's the next available appointment. Which one do you want? I mean, it could just go from there. This is like the spider web once you get into that. And we talked about ecosystems a lot in a few previous episodes. Plastics are a big thing. And our friend Scott sent us an article on enzymes that can actually digest plastic. So since the 1950s, obviously, we've produced a whole bunch of plastic, which are breaking down into microplastics and now even nanoplastic. And 35 million tons of plastic waste just in 2017. That number has gone up, and only a very small percentage of that gets recycled. So these things called PET, which is polyethylene terephthalate, is the main key contributor to plastic waste, predominantly from food packaging, things like that. And they have this thing called cutinase or cutinase. It's an enzyme known for its ability to break down PET. It comes from Fusarium solani, which is basically a bacteria. It's an enzyme, and it shows the ability to degrade these plastics. And even the discovery of a leaf and branch compost, which broke down plastic as well. So natural organic things that just have the right mix of digestive enzymes that can even break down plastic. And they're even coming up with a hydrogel for the ocean, which basically we know all the reasons why pollution gets in there, but how do you get it out? There isn't a net big enough or fine enough to catch it all, and that's not practical. But they have these gels where water can penetrate, but all the sediment would get stuck. So basically, this is like that gel have you seen for cleaning your keyboard? You smush it all in your keys and then and all the gunk comes out of it. Mm-hmm. Basically, that's a very dumbed down way of saying what this stuff would do. But effectively, you know, even like self-embedded nanoparticles. So they could put these silver particles in what's called cotton gin waste. So the production of cotton produces this stuff called gin waste. It's a byproduct of the ginning process when the fibers are separated from the seed. So the treasure is its hidden potential to transform silver ions into silver nanoparticles and create new hybrid material that can be used to add antimicrobial properties, aerogels, packaging, composites. You could make hospital surfaces out of this, ambulance, touch surfaces, basically things. Bacteria can't grow on silver nanoparticles. So it's an easy way to antimicrobial stuff by embedding it right in the fiber. So you could literally wear clothes that would absorb or protect you from various bacterial or other pathogens, right? So not only the Internet of Things, but the metamaterial of things and your clothing and everything you interact with and touch. What if you had, your cell phone had a way of delivering vitamins right through your porous skin?
Yeah.
You're vitamin D deficient, but your phone just gave you some, like all this stuff becomes possible because now we can manipulate the nano level, things that are smaller than even our smallest microscopes can see. And you can do a lot when you're at that size, right? Even like We've showed video clips of little medicinal robots, or kind of like robotic cells that could clean out cholesterol, or it could be sort of notified whenever you have an infection or a virus. It could tell your body to produce more or less of certain chemicals or antibodies. So, the world of nano and micro is a big deal. If you like that, check out our episode that we did a while back on nanoparticles and nanotechnology. And we do a definite deep dive on that. And the last thing I got before I'll throw it to you, Marquise, is the quantum crystals. So basically, electrons, these sort of infinitesimally small particles, they zip around atoms, and we learn more and more about them all the time. But now at Princeton, the understanding has been pushed. So direct evidence of what's called the Wigner crystal, a strange kind of matter that's made entirely of electrons. So the Wigner crystal is this article says it's one of the most fascinating quantum phases. So essentially, Al Yazdani and James McDonald, professors from Princeton. So visualizing the crystal allows us not only to watch its formation, but confirming many of its properties that in many ways that you wouldn't. So basically, if you've seen the slit test, or the idea that the observer in a quantum example has an effect on the end result, we can manipulate that for the end result. So using that quantum randomness and the role of the observer, we can have particles form material, even though they're basically not matter, but they can form matter. And it's they still don't fully understand the extent of how that's going to work. But again, we're talking about engineering things atom by atom, electron by electron, using the master ingredients list to essentially make whatever you want in a very easy, cost-effective, and it might even come down to as simple as just thinking it into existence. Maybe it's some type of gel that you give it an intention and it becomes a certain polymer or whatever, because it's behaving at the quantum level, and we all interact at the quantum level. So this isn't just science and chemistry. This is advanced physics and the quantum world, which is weirder than we can think. When you put all those things together, it has a recipe to do some stuff that we cannot even imagine at this point. But I think in the future, AI will help us get there. It'll help us think in ways we wouldn't have normally thought. It's really going to speed this type of material science up. And I think you're going to start seeing more and more of this even leaching into your day-to-day electronics. And you'll see more and more articles and science topics about this, more discoveries as a result. Because if you now have a new material that you didn't, you have a whole bunch of things you can do with that material, and therefore more practical applications. So the more materials that are discovered, the more they understand how they work, the more they can manipulate that to do the things we're having a hard time doing. And I think if we're ethical and we're responsible with this, it might be exactly what we need, because we've got a lot of problems right now. So final thought to you, Marquise, before we close out.
I'll try to make this brief, okay? I have two thoughts. I'll try to blend them together. I had a conversation, a very brief one, from a post on Facebook recently, where I talked about how I wish I could make people care. And it kind of evolved into some really interesting, comments in the comment section. I really appreciate them, by the way. If you're watching, thank you for the input. A lot. I appreciate that a lot. But there is a perspective that I've held for quite some time that is contrary to popular thought. And it has to do with the idea that the way that we are as a civilization is not natural. The idea that, for example, vanity is the ultimate aim for humans. The idea that freedom is, and from our perspective, the ability to do things that have no true value to your life actually at all. They only kind of perpetuate the chaos that our civilization it somehow just is full of chaos, full of this division and strife and suffering. And I do not believe for one moment that is our natural state of being. I think that's ridiculous to believe that our natural state of being is that of suffering. Now, when I say suffering, I don't mean you're hungry and you should never be hungry, and therefore the feeling of hunger is that of suffering. At its core, you're suffering in some way. Having to use the bathroom and not being able to do it right away, that's suffering. Being sad for whatever reason, being hurt from falling and hitting your knee, all these things are suffering. They are natural. That is natural suffering. But when we are imposing unnecessary suffering as a consequence of our civilizations, like our culture and our way of life, that is not natural, and it's not something that we should just accept. Now let me blend that into to the next part of my perspective here that I think is important to talk about. We as a civilization, we again focus on the vanity of life more than we think about the necessity and the idea of thriving. We are all just trying to survive. And instead of coming together as one civilization, we separate ourselves by culture and geographic location as if we don't live on one planet, floating through the freaking solar system and but a galaxy that is part of a greater universe. We think of ourselves as a part of a nation, and even worse, sometimes a part of a neighborhood. Very simplistic, very simplistic, and honestly primitive when you think about it. And unless we supersede that primitive inclination that we somehow, for some reason, have, that I do not believe is our natural state of being, we will never achieve the kind of future that we talk about all the time here. And that's a future where we're all unified, connected in consciousness, thought, and also action, not like the Matrix where we're all plugged into a machine and thoughts are forced on us, but that we just naturally align with each other because we share the same goal and aim. And that is for the thriving of human civilization versus just the surviving of our individual, of our individual desires. That just sounds, it just, please help us push the idea that humans' natural state of being is one of thriving. And the futures that we talk about, the ones that we explore here on the show, the technologies that we're always presenting to you, they're not only possible, that they could just be the stepping stone to a greater future that we can't even imagine in our current state of mind. But we'll never get there. We'll never even begin to get there by believing that the way things are now, is natural, because it's not. And again, I know it's not a common thought. I know it's a very uncommon perspective, but I think it is on at least the right path.
Well, will the future be a utopia or dystopia? Only time will tell. Both probabilities are equally possible. So really, it's going to come down to humankind, what we do with this newfound power. Our track record hasn't been great, but now we're playing with things that might make it easier for us to align because we all have common goals. Maybe you are a oil tycoon and half of your family gets sick and dies of cancer, and you realize that pollution was part of the problem. Maybe you spin around, your perspective has now changed. That's just an example. But at some point, things will get bad enough that if we're all fighting for water, our small differences don't seem as big as they used to anymore. Maybe we can then get behind the same initiatives and actually make some things happen. In the meantime, we got a lot of work to do, but that's why we like doing these shows, and that's why we like having everybody alongside of us. So thank you, everybody, for being with us today. On behalf of my co-host, Marquise Williams, and myself, Louis Borges, thanks again for joining us and checking out our show. If you haven't yet subscribed, please do so. And please join our Quantum Club. Link is in the description. Check out our sponsor, H2 Water Expert. Until then, we'll see you next week at 9 p.m. next Thursday. Thanks for joining us, everybody. Have yourself a good night.